Okay, so I'm making a new video for SAS 2. That way it's not as long. So I'm going to go ahead and tell you, in your workbook, we are doing, we're on page 185. We're doing number 1, number 2, number 4, 5C, number 6, and number 12 and 13 you will be doing on your own for exponent practice. However, later this afternoon, I will be uploading a document to Teams, and I will also email it out as well. The answers, so you can check yourself, and I will also work out the problems and show you the work behind it. Okay? So, on number 1, this is rational exponents. So, first, before we even begin, I want you to write what I've written in blue on your paper somewhere around number 1. While you're doing that, I'm going to look for my pen because I just dropped it and I don't know where it went. Okay, I got it. So, what we're going to do is we are going to rewrite each example. Maybe not all of them, just a few of them. Because they're all the same. So, the first one, we have a negative 64 raised to the power of 1/3. Okay? So, we are looking from here to go to here. Okay? So, my B is a 3. So, I'm taking the cube root of negative 64. Now, my A is a 1, so do I really have to write that? No. You only want to write that if it's a number besides 1, because we know anything to 1 is itself. So, we don't need to do that. All right, so on the next one, we have a B, a root of 3, an X of 27, but 27 should be raised to what power underneath that radical? 4. Okay? Now, C is a little bit different because there's a negative. So, you just attach the negative with your B and roll on. So, we have a negative 5 and a 32. Okay. Next, we have a cube root of 125 raised to the 5th power. On E, we have a cube root of just a simple 8. On 16, we have a square root. So do we need to write this too? No, we don't need to. So this is the same thing as 16, the square root of 16. So let me point out, this is important to know. Anytime something is raised to the 1/2 power, that's a quick thing you need to know. Oh, that's the square root. That's just a quick thing you can know. It'll save you time. Put that in your head. Anything raised to the 1/2 power is the square root. All right. G would be a negative 4 with the 16 underneath the radical. All right, 8 would be a few different things. So I'm going to write it underneath it. So we have this 27 squared. And then here's an exponent rule. We have 3 to the -1. Remember, we don't like negatives. So guess what I should do? Put it on the bottom. So that's a 1/3. Okay. The last one would be a -5 with a 32 times the square root of 16 cubed. Okay. Now, all of these you could type in on your calculator. If you want, you can use the calculator on Agile Mind, or you can always go to desmos.com and you'll have a real scientific calculator like you would in class. So, either one if you want to solve them. I just wanted you to know how to change this exponential to a square root, or to a whatever root, cube root, 4 root, 5 root, whatever it is. Okay? All right, so now I'm going to go to page 2 on Agile Mind. And this is number 2 also, so I'm going to go ahead and hit play. I'm not sure what it's going to do. Oh, it's comparing. So it's showing you that our bases are the same. All right, so on the 2 examples that we have in our book, notice that all the exponents are the same, except in example 1, we have actual numbers for our bases. In example 2, we have actual letters. So, I'm going to hit number 2, and we're going to see what it's going to do. So, it is showing you that is correct, but I think I'm going to do it on my own so I can show you what the easiest way for you to do it. All right. So, let's go ahead and let's simplify. Oh, I know. Okay. We have 2 to the 6th, and we have 3 -2 over 2 -3 and a 3. And all of that is to the 1/3 power. Now, do we like negatives? No, we do not like negatives. So let's change it where everything is positive. Okay? So I'm going to erase this one. And I'm going to erase this one, because those were negative. Now, I'm going to swap their spots. So I'm going to have a 2 to the 3rd here and a 3 to the 2nd power here. Now I can combine. So since my bases are the same up top, I have 2 to the 9th, right? 6 plus 3 is 9. On the bottom, I have 3 to the 3rd, right? Okay. Now, all of that is still raised to the 1/3 power. So now we use the power rule. So I say 2, 9/3 over 3, 3/3. If I simplify, 2, what is 9 divided by 3? 3. And what's 3 divided by 3 in the bottom? 1, so I have 3. Okay? Now, I'm going to let Agile Mind show you the way that they do it again. Let's see. Let me click the 2 again. All right. So, what they're doing, so right here, they brought their problems down. Okay? Now, watch what they do next. They swapped those. Okay? They put the negative exponents in the bottom. And look, they moved their places. So it's the exact same thing that I did. Okay? Now, on 3, they're simplifying. And they're going to have 2 to the 9 and x to the 9. They're going to have 3 to the 3rd and y to the 3rd. They're going to use the power rule. And they're going to simplify. Okay? So, there is my work. So, if you want to go ahead and copy that for the second example, it's the exact same thing, except they use x's and y's. All right, we are skipping number 3, and we are going to number 4. So, on number 4, we have to do some matching. So, first, I'm going to write out to the side. So, this first example, we have 2x squared. Okay, so that's the same thing as me saying 2x times 2x, which would give me a 4x squared. Now, before we knew our exponent rules, this was the way we knew, right? And you can still go that way. However, what I'm about to write is using the exponent rules, using the power rule. So I would say 2 squared times x squared, which would be 4x squared. Okay? So they are both the same thing. Either one is correct. One is the old way, one is the one using exponents. So this one would be right here. All right. The next one to the right, we have 2x to the negative 2. Okay. So, here we would say, well, negative 4. Well, let me back up. Let me write it out for you. We would have 2 to the negative 2 times x to the negative 2, right? So, 2 to the negative 2 is a 1/4 x times x negative 2. But remember, I don't like negatives. So this is really over 1. So if I put it on the bottom, then I'm left with this right here. Another way you could do this is you know that 2x to the positive 2 is 4x squared. So you know if you use the negative rule, then it's going to have to be moved to the bottom. Okay? All right, the next one, can you simplify the next one at all? Does it have any parentheses that allows me to do the power rule? Nope. So I'm just going to bring this down right here. Okay. Now, let's see. All right, so on the last one, if I break it up, I have a negative 2 and an x negative 2. Those are the same thing. But this right here is negative, and I don't want that to be negative. I don't like that to be negative. So right now it's on the top. So what should I do? Well, I can't do nothing with this -2, but I can do something with that x -2. I can put it on the bottom. So now my answer would be, whoops.
Negative.
It's talking. There we go. Okay. Let's see. Next, we want to go to 5C. We're just simplifying. All right, so on 5C, I want you to write the expression that is on 5. (12x squared y -3) 4x6 y8 and a -1/2. All right. So, first thing we need to do with that first set of parentheses, you have to look. Do you have any negatives? Yes, you have a -3. So, we got to change that. So, we have 12x squared on the top. We have to move our y to make it positive, so we have a y3 on the bottom now. Okay? Now, here, do we have any negatives inside the parentheses? No. But we do have a negative exponent on the outside of the parentheses, which allows me to do the power rule. Okay? So, let's see. All right, so we take each part and we raise it to the -1/2 power. So we have 4 to the -1/2. We have x to the -6/2. And we have y to the -8/2. Okay? Now, I want to simplify, though. What is -6 divided by 2? -3. And a -8 divided by 2 is a -4. Everybody agree? Okay. So now, we need to change something. So, let's see. I'm going to erase this, and I'm going to rewrite it for us. So we had 12x squared. Let me erase that. (12x squared) and y3 in the first set times 4 -1/2 x -3 and y -4. All right, so now you have to look. Do you have negatives? Yes, we don't like negatives. So, 4 to the -1/2 is 1/2. Now, we have x -3 and a y -4. Those are on the top now, but they've got to be on the bottom. So now I can simplify. Okay? So remember, always write your coefficients first. So 12 and 2. On the top, I have an x squared. On the bottom, I have an x cubed and a y 7 because I combined 3 and 4. Now I have to subtract my x's, so I'm going to move up here. So I have 12. Well, let me back up. What's 12 divided by 2? 6. And then I have an x. 2 minus 3 is a negative 1 over y7. But there's a negative. So guess what I do? I leave 6 on the top and I move x to the bottom. All right, so number 6 is kind of like a puzzle, I guess. So you got to fill in the blanks. So on the first one, we're looking at the exponent that should be attached to the y. All right, well, if you look at your answer for the y, you have a y squared. Okay, and we know we're going to have to use the power rule because it's got the power of 3. So out of my choices, does x times 3 give me a 2? No. Does y times 3 give me a 2? No. Does negative 4 times 3 give me a 2? No. 27? No. 6? No. 2/3 over 3. Well, 3 times 2/3 is 6 over 3, and 6 divided by 3 is 2. So, the first one would be 2/3. So, you see how I say it's a puzzle? All right, the next one, we have a y to the 4th, and we have, or x to the 4th and a y to the negative 2, and our answer is y over x squared. So we know we're going to have to use the power rule again because it's looking for that power that we would multiply by. So, we know it can't be a letter. And we've already used, let's say, 2/3. So, let's look at our numbers. Is 4 and negative 4 like 2? In order for us to get this positive 2, it would have to have been an x negative 2. So keep that in mind. Let's see. So it's not negative 4. We know it's not 27. We know it's not 6. We can eliminate all of our big numbers, basically. So we're left with these two, negative 1/2 and 7 over 2. All right. So if we said 4 times negative 1/2, we would get negative 4 over 2. Well, that's a negative 2. Isn't that what I'm looking for? Because I would have to move it to the bottom. Yep. So we have this. All right. The third one is really easy. So look at your problem and your choices. We're looking for what the x would be. So we're using the power rule. So we have x negative 7 to the 1/2. Well, that would have to be x negative 7 over 2. So it's negative, so I would move it to the bottom to get positive 7 over 2. Right? All right, now we're looking at the bottom example. So we're just looking for the y because it's what it asked us for. So we started with a y cubed, and I need a y something to get just a y. So remember, we're multiplying, so we have to add the exponents. So is 3 plus x y? Nope. 3 plus y? Nope. 3 plus negative 4. 3 plus negative 4. Well, that would be a y negative 1. But since this y is on the bottom, you would have to move it. So that is correct. All right, the next one has to be a whole number. So, let's see. We've used 2/3, we used negative 1/2, we've used 7/2, we used negative 4. We know it has to be a number. So we're down to these 4 answers. Let's see. 6 divided, if I put in a 27 over 3. Well, let's do it like this. Whatever number this is, it's going to have to be multiplied by this. Or raised to the power. So we have a 27 2/3. We have a 6 2/3. We have an 81 2/3. And we have a 3 2/3. So, let's go to our calculator. And let's do 27 2/3. And we get 9. Okay. So that would be, if we did 27 2/3 and x that'll be x squared over 3x to the 5th. Well, 27 2/3 left us with 9. So we have 9 over 3 an x squared and an x to the 5th. So that's 3. And then we subtract those exponents. So x to the negative 3rd. But that would have to be 3 over x 3rd. So our answer has to be 27. So do you... Whoops, what is this? So do you see why I say this is a puzzle? It's a trial and error kind of deal. Okay? Now, on the last one, what are you supposed to do for the negative rules when you have a negative exponent and it's a fraction? Flip back to page 182 and you do what to that x and that y? You flip it. So this would be y and this would be x. Okay? So, the only way you are going to master these rules is to just keep working and keep practicing, which is why I want you to work on number 12 problems and number 13 problems on your own. Instead of me going through them with you, I want you to actually try some on your own. Later this afternoon, I will upload the document showing you the correct answers and how to work it. And if you have questions, of course, you can always let me know. Have a great day, guys. See you soon.